Let's start off with what is AI inbreeding. AI inbreeding is the process where models are trained on data produced by other AI systems, causing gradual loss of diversity and accuracy. Left unchecked, it can lead to model collapse that makes AI less reliable. Artificial intelligence has thrived on vast, diverse datasets drawn from human-created text, images, and code. When those datasets become saturated with AI-generated content, future models risk learning from degraded signals rather than original human sources, producing outputs that echo and amplify earlier model errors and biases. Researchers and commentators have likened this feedback loop to biological inbreeding. Successive generations become more uniform and less robust because they inherit the same flaws rather than fresh variation. The mechanics of this phenomenon are straightforward but alarming. Models trained on synthetic outputs tend to converge toward the average of what came before, losing rare but important variations. Experiments show that repeated retraining on model-generated data can produce blurred images, repetitive text, and collapsed distributions of features. In controlled studies, iterative generations of image and text models produced steadily worse and more homogeneous results after only a few cycles, demonstrating how quickly quality can erode when human-authored data is displaced. The consequences extend beyond aesthetics. Homogenized models can amplify biases, reduce factual accuracy, and make AI systems brittle in novel situations, undermining trust in tools used for search, content creation, and decision support. As AI content proliferates online, distinguishing human from synthetic material becomes harder, complicating efforts to filter training corpora and increasing the risk that future models will eat their own tail, a process some researchers call model autophagy or Habsburg AI. Addressing AI inbreeding requires a mix of technical, policy, and cultural responses. Possible mitigations include stronger provenance tagging or watermarking of synthetic content, curated human-centered datasets, and training pipelines that prioritize diverse, high-quality human sources. Industry actors already expend significant effort cleaning scraped data. Scaling those efforts and investing in detection tools will be necessary, but not sufficient, because synthetic content can be subtle and hard to identify as it improves. Equally important are incentives and norms that encourage disclosure when content is AI-generated and public funding for open, representative datasets. AI inbreeding is not an inevitable collapse, but a solvable engineering and governance challenge if recognized early. Protecting the diversity and integrity of training data is essential to preserve AI's usefulness and fairness. If researchers, companies, and policymakers act now,